Okay, so the infield of the baseball field is a square, right? Even though they call it a baseball diamond, that's lame because it's really just a square tipped up on its side.
This is a diamond.
Right? So, I get so frustrated. Well, my mom used to teach preschool. Now she doesn't anymore. She's tired, but she used to teach that was a diamond. I'm like, Mom, that's why kids get to me and they can't do anything, like, because they think that's a diamond. It's a square.
What'd she
Like they have
teach
to
it?
think outside the box. Mansfield. She
I
also
have
used to
her.
teach. You did not. What was her name?
You're also recording.
You know Miss
Morris.
No.
That's my mom's last name.
You know the Maziano name.
Oh, Mazzioni.
Yeah,
No.
Maziano.
Okay. Well, she used to also teach that oval was a shape, even though I told her it was an ellipse, not an oval. Okay, but anyways, so this is a baseball square, and the distance from home plate to first base is 90 feet. All of those are actually 90 feet. We know that because it is a square. So all of these are going to be 90. Okay, and then let's see. It says, what is the distance from home plate to second base? All right.
45, 45, 90.
We know that we have 45, 45, 90s because I basically took the square and cut it in half. So this was 90 degrees. Now this is 45, and this is 45. So if the leg is 90, then what is the hypotenuse?
90 times the square root of 2.
90 times the square root of 2, whatever that decimal would come out to be. 14 says, what's the distance from third base to first base?
Well, that's the same thing.
It's going to be the same thing. It says, if the pitcher's mound is 60 feet 6 inches from home plate, is it the midpoint of the diagonal from home plate to second base?
No.
It actually isn't, even though in this picture it looks like it is. What's it closer to? It's a little bit closer to home plate, right? So if it's 60 feet 6 inches, right, to figure out whether it was actually the midpoint or not, you just find the decimal approximation of this, which is the decimal approximation of 90 square root of 2 is going to be 90 times the square root of 2, 127.3, and if I divide that by 2, it's 63.6 feet. Right? Well, 60 feet 6 inches is a little bit closer than that, so no, it is not the midpoint. Got it. Okay, that's that one. All right, let's take a look at number 7 here. All right, this is a 30, 60, 90 triangle. All right, now my hypotenuse is 6. Now which side should I be going after here? Short leg. So how is the short leg related to the hypotenuse?
No.
This is 2 times. So what's the short leg? 3. Now how do you get from the short leg to the long leg?
Multiplied by square root of 3.
So what is this?
3 right.
Okay, number 9.
Oh,
Wait, how'd you
I
know?
got it messed up.
It's always the same ratio. Always. The hypotenuse is twice the short leg, and the long leg, you take the short leg and you multiply it by the square root of 3. Always, always,
I
always.
always thought it was the other way. I thought it was
So if it's since there's x, the x is 3,
Mm-hmm.
and then the long leg is square root of 3.
You take the short leg times the square root of 3. So if the hypotenuse here was 20, what would the short leg be?
20 square root of 6, 3.
The hypotenuse is 20. The short leg is half of it,
10.
10. So what's the long leg?
120.
10 square root of 3. So always whatever the short leg is times the square root of 3. So if your long leg is 120, what's the short leg?
Half that's 60.
60. So what's the long leg?
60 square root of 3.
You got it. Okay. So now this one's a 45, 45, 90, right? How do you get from the leg to the hypotenuse?
Divide by radical to radical.
Listen to the words coming out of my mouth instead of the words that you're interpreting coming out of my
Alright,
mouth.
ask it again.
How do you get from the leg to the hypotenuse?
Multiply by radical.
Multiply by radical 2. So how do I go backwards? divide by radical 2. So I've got 12 divided by radical 2. That's x. But I can't leave it that way because it's not rationalized. So how do I fix it? Okay, we multiply by radical 2 over radical 2 because that's a 1 in disguise. So I'm going to get 12 square root of 2 over 2. Is that simplified? These are both even. So I'm going to get 6 radical 2. That's x. What's y?
X equals Y.
They're the same in a 45, 45, 90 triangle. That's it. Any other ones from that worksheet? Pretty good. All right, last section of the year. I'm not sure what that was. It was like a half cry, half elation.
Did you even hear what I said earlier?
No.
I said if you have the 7-8 thing, I can come 8 because how many classes are you allowed to have on a full schedule?
8.
8. Okay, well I don't have 8 period. I mean I don't have the last period. I can just come in that.
I got you. You're welcome to come.
No. I can't because if that's 8 is the last period.
Okay, what is a radian? All right, here's your definition here. Radian is a new angle measurement. Right, it's not the same as a degree. So when we're working with radians, you're going to have to change your calculators to radian mode. Otherwise, it won't do the correct calculations. All right, a radian is the angle required to make the arc. All right, now this is a word that you can use it with your friends today and make yourself sound really intelligent. Subtended, right? I like that. Andy, if I see subtended in Words for Friends, I will be so proud of you.
Might have to use this.
Especially because it requires more letters than you have time. Subtend. There you go. All right, so a radian is an angle required to make the arc subtended by a central angle equal to its radius. All right. All right, so what this means is 1 radian, right, is the amount of arc, right, so this curved distance, right, so that this is the same distance as this straight distance here. Okay, I think that worked out. So we usually, whenever we're dealing with radians, we're usually dealing, like, you'll see theta instead of x's, right? You'll see this theta thing. That usually means that your problem's going to be in terms of radians, right? And what we're saying is that if this arc here is 4, then this radius is going to be 4. So the radius's distance is the same as this curved distance around here. When that happens, your angle is considered 1 radian.
Okay.
So how long would an curved arc be if I had 2 radians? In this problem, it would be 8. Right? In general, the arc length would be twice the radius, right? Because that would be 2 radians. Right? So 1 radian is what it takes in order to get this arc length to be the same as this radius. Right? So if I were able to, if this red line were pliable, I should be able to take that and wrap it right around here, and it would fit perfectly in that little angle. Okay. All right, so we get this little formula here, SRO, right, or SR theta, but I always think of it as SRO because that means something to me. Do you know what it is? Not SRO. SRO, like if you buy a ticket, it's SRO. Do you know what that means? Standing room only, right? Standing room only. General admission, right? So your S stands for arc length because arc length starts with an S. And also invisible. R, obviously, stands for radius, right? And then what do you think that the theta stands for?
Theta.
Angle.
Theta is theta. What kind of angle, though?
Zero.
Radians. It's got to be in radians. Degrees will not do. If it comes in degrees, you have to switch it to radians.
Does radians have units?
They're just radians
Just radians.
as opposed to degrees. Okay, so if I want to find the length of an arc of a circle with a radius of 9 centimeters, and it's subtending a central angle of 60 degrees. All right, let's take a look at what that's actually going to look like. Let me pull up a circle here. All right, so if I've got a circle with radius 9 centimeters, and an angle of 60 degrees, I want to know what this arc length is. So what am I solving for in this formula up here? I'm looking for S. Right, so S equals the radius, which is 9, times the angle in radians. So what did I give it to you in? Degrees. All right, so we have a problem. We will come back to that problem. Let's take a look at this first so that we can get the tools in order that we need it. 'Cause right now, I need radians in that problem, and all I have is degrees, and I don't know how to switch it. So here's a question that some geometry teacher should have asked you somewhere along the line, but 99% of your geometry teachers out there just tell you what pi is, and they don't explain to you where pi came from.
So if you circle.
What is pi?
Good.
Not that kind of pi.
It came from a dude who
Did it come from
Did
the radius? Did it come from Copernicus?
I don't know who described it, but what? All right. What do you guys know? Tell me something about pi.
it's not it keeps going.
It's a decimal that never ends and never repeats. What is the decimal that the approximation that we use? 3.14. Now that's meaningful. All right, that 3.14 means something. Does anybody know what that is?
It's the radius divided by something, right?
At the end of the year.
It has something to do with circles.
It does have to do with circles.
Something about a circle.
360 is 4 circles. So
All right.
You like take the circle and divide it up or fold it around, and you do something with it. It equals that.
Sort of. You're not awful. The explanation. All right. I am going to pause this because I'm going to show a physical demonstration
Like the circumference or something.
that I haven't done in a while. It has to do with the circumference.
Yes.
Let me see what I can do here. But it's not going to be any good to anybody watching this video, so. Pi times diameter, because 2 radiuses give you a diameter, right? So pi d also equals that, okay? So hang on to that for a minute, right? So if I want to see how many diameters it takes to get to my circumference, what would I do to find that out? Divide them. What is 211 divided by 65 approximately?
5926.
I don't know.
5.
211 divided by 65 comes out to be, all right, that just means, it's close though. It comes out to be 3.2.
It's close.
Right, if I had string, it would be
That's
better.
human here.
This stuff stretches pretty good, so that's why it was a little long. Right, so it comes out to be 3.2-ish, which is in the ballpark of 3.14, right? So what does that tell you? If one diameter goes around the circumference 3.14 times. That's what pi is. Pi is the number of times it takes to take a diameter and wrap it around a circle. You'll get that diameter around there 3 times and a little bit more.
Whoa, why is there a why?
Oh, because I had measured around it with a string,
You made a hex.
and then we measured the string to see what the circumference of the circle was.
You just have that started.
No, I don't want to summon something.
It's his
So
protection.
that's where this formula comes from. The circumference is the diameter times 3.14 because it takes 3.14 diameters to get all the way around a circle. Right? Now you know what pi is. It's the number of diameters that it takes to get around a circle. Right? Someone should have taught you that somewhere along the line, but I know very few geometry teachers that do.
I had Mr. Kofa.
Wait, he is awful.
Hey. Okay, So pi represents the number of diameters it takes to complete the circumference of a circle. All right, so one revolution around the circle would be how many radians? What's a radian represent?
When I know what the length of the radius equals the arc of the angle.
Right, so we need the arc of that, the arc to equal the radius. So how many radians will it take in order to get all the way around the circle? Come on, do it, do it. Where is it? It's there somewhere. Oh, come on. There it is. 2 pi's, right? Did somebody say 6? I thought they said 6 radiuses, right? It'll take 6 radii in order to get all the way around there, right? So that's 2 pi's, right? 180 degrees then is how many radians? If one revolution, how many degrees is that? 360. So 180 of them is going to be how many pi's?
Half.
Half of that,
Yes.
right? So 1 pi.
So I said half. Oh.
Right, so if 180 degrees is 1 pi, then this one is already revealed. 1 degree would be pi over 180, because I would take 180 degrees and divide it by 180 in order to get 1 degree. So I'd have to do the same thing to the other side. So my pi over 180 would actually equal the same amount as 1 degree. So 1 radian is going to be how many degrees?
180.
Take a look at it.
Oh, I was right.
180 over pi. So these are the 2 major things that you need when switching between degrees and radians. Right? So if I want to convert 60 degrees, which is what we need for our problem, right, to radians, right, my answer is going to have a pi in it. So if I want to convert 60 degrees to radians, I multiply by pi over 180. That'll get me 60 pi over 180. Does that simplify? 60's in both of them, so what am I going to get?
Pi over 3.
Pi over 3. These are the same. If I want to switch 150 degrees to radians, what do I need to do?
Multiply by pi over 180.
Yeah, multiply by pi over 180.
Yeah.
Someone must be
Multiply by pi over 180.
Multiply by,
Pi over,
come on, see ya. Multiply by pi over 180. That's going to give me 150 pi over 180.
Go ahead and divide that by 30.
30 goes into all of these. How many times does 30 go into 150? How many times? There you go. This is the same as that. Now, negative 45 degrees. Should I change my pattern because it's negative? Nope. Do it exactly the same. So it's pi times 180. It's going to get negative 45 pi over 180. Divide, well, actually 45 goes into both of these. How many times does 45 go into 180? 4 times. So I'm going to get negative pi over 4. These are the same. So if I want to turn 90 degrees into radians, multiply by pi over 180. That's 90 pi over 180 equals, so pi over 2. These are the same.
I like turning math to sing songs.
Yeah? Like Mr. Schneebly?
What?
Yes.
I love that one.
Wait,
What the hell is that?
School of
School of Rock.
Massive.
Or rock.
Right.
Yes.
I don't get how you come up with the answers. Like I get the middle step, but I just don't.
Multiplying everything by pi over 180. Then we just simplify. So like here, 150 and 180, what do they have in common? 30. So we divided both by 30 to simplify. In the same way that if I have 2/4, that's not simplified because they're both even. That's really 1/2. Okay, that's all we're doing.
Got it.
All right, so how do you convert degrees to radians then?
Multiply.
Oh, I'm sorry, convert radians to degrees. Listen up.
Multiply the reciprocal, so we multiply 180 over pi.
Right. So I multiply by 180 over pi. What happens as a first step here?
You just
Pies
multiply
cancel
across.
out.
Pi's cancel. So I'm going to get 180 over 6, which is
30, yeah,
30 degrees. Right? Same thing here. I multiply by 180 over pi. The pi's cancel. So I'm going to get, what? Can I cancel anything else?
yeah, 2 and then 180.
2 into 180, how many times?
No,
90.
So 3 times 90 is
270.
270 degrees. Multiplied by 180 over pi. The pi's cancel. Is 4 going to 180?
Yeah.
How many times? 45 times. So 3 times 45? That's a harder one.
135.
135. And it's negative because I had a negative here. So negative 135. Good. Yes.
Problem with that. But when I try to do that with the whole other problems, the whole cross multiplying, you
Yep.
said I couldn't do that. But you just did it, and then you said you're gonna cross multiply when there's an equals.
Correct. I didn't cross multiply. I cross canceled. You can cross cancel because if I took this problem right here, pi over 6 times 180 over pi, let's say I didn't cross cancel, right? And I just multiplied straight across like I want you guys to do. So 180 pi over 6 pi. Now, what's the rule on simplifying?
I was still 30.
Anything that's in the top and the bottom can simplify, right? So I had pi's in the top and the bottom, and both of these have 6 in common, so I get 30, right? So all I was doing here by cross canceling is saying, well, all of these things are in the top. All of these things are eventually going to be in the bottom. So you can cancel anything on the top or the bottom, even if they're not directly over each other. You can cancel on the diagonal as well, because eventually they're going to end up where they're over top of each other. So I was just cutting this step out by cross canceling.
Did you cross multiply?
No,
It wouldn't work.
only if there's an equal sign between them. When there's a multiplication in between them, you got to go straight across.
So you
What if I'm able to cross multiply and it works?
It would be coincidence. Okay.
So you're multiplying because one of those things that they look like a subtraction sign.
Yeah. The only times that cross multiplying in a situation, no, I can't even think of where that would work.
Could you scroll?
Yeah.
Could you scroll to more?
You can go around.
Yeah.
Okay.
Switch his head.
Okay, you are going to be asked to fill in this unit circle.
Oh, this is the one that.
Okay, now the unit circle, as taught by teachers that have taught this forever, it can be really tedious and really hard to memorize. Being taught by a new teacher that gets it, this is really easy. Who can count? I should see
Yeah.
all hands in the air. Okay, then you guys are going to be awesome at this. You need to memorize 2 things.
Sound like Billy Mays.
2 things.
Right.
All right.
Or Anthony himself.
Right, we're going to do this in degrees first, and then we'll do it in radians. Okay?
Wait, can I be down?
The unit circle? Sure.
You said only 2 things, so we need to know.
You need to memorize 2 things, and then if you can count, you're going to be in good shape.
So, but when I count personally,
Mhm.
I count by prime numbers only.
Oh, that's more
So,
challenging.
you know, I go 1, 3, 5, 7, stuff like that.
Yeah. What would be the next one?
11.
Oh, okay. Just checking.
And then 13 and 17, you know, easy stuff like that.
Mm-hmm.
And then
21.
No, 19.
Oh,
Duh.
good.
I only count by prime
I
numbers.
was trying to throw him a curve.
Yeah,
Okay.
right.
That's how I count.
That is weird.
Okay,
Okay.
Problem.
Number 1 thing that you need to memorize is that this is 45 degrees.
All right.
Now, if I keep going 45, and this is going to be my 0, right? We learned that yesterday. All right, so if I go 45 degrees, now if I go another 45 degrees, I'm going to end up here. What's that?
90.
90. If I go another 45 degrees, that'll get me here, which is what?
35.
135. If I go another 45 degrees, I'll be here, which is 180. If I go another 45 degrees, I'll end up here, which is 25. If I go another 45 degrees, I'll end up here, which is And if I go another 45 degrees, I'm going to end up here, which is,
No, 3.
15.
and if I go another 45 degrees, I'll end up here, which is,
360.
does that make sense? Yeah, because if I go all the way around, then my coterminal angle to 0 would actually be 360 because I went all the way around. They end at the same place. Right? That's one thing. Right? The next one is this one here. It's 30 degrees. Right? So I go 30 degrees. If I go another 30 degrees, I'll be at. If I go another 30 degrees, I'll be here. I already have that one. If I go another 30 degrees, I'll be here. If I go another 30 degrees, I'll be here. And another 30 degrees, I'm already at that one. 210, 240. I already had that one. 300.
330.
Ooh, I missed this one. 330. And if I go last one, 360 again.
That it?
That's for the degrees.
So that's
Right.
one thing.
Well, no, I haven't got to the one thing you need to memorize. I'm pretty sure the degrees you can handle. Right? Now, here we go. Ready?
Yes.
Let's take one of these things and convert them to radians. We started with the 45 degrees before. How do I convert degrees to radians?
Multiply by
Pi over 80.
180.
Okay, so 45 degrees times pi over 180 gets me 45 pi over 180, which it simplifies to.
Pi over 4.
Got to memorize that one.
Pi over 4.
Now we can count. From here to here is 1 pi over 4. So what will this be? 2 pi over 4, which simplifies to.
Pi over 4.
1 pi.
2 pi over 4
Is
One half.
over
pi over 2. Okay, if I go another one, this would be 3 pi over 4. If I go another one, this would be, which simplifies to
Pi.
pi. If I go another one, I'll be at
5 pi over 5 is 16.
5 pi over 4. If I go another one, I'll be at
60.
6 pi over 4.
6 pi over 4, which simplifies to
2 pi.
3 over 2 pi.
3 pi over 2. If I go another one, I'll be at
7 pi over 4.
7 pi over 4. And if I go another one,
8 pi over 4. Simplifies.
and this was at 0, not degrees,
I like that word, simplifies.
which would be 2 pi. Okay? So if you can remember that 45 degrees goes with pi over 4, now you can just count them out and simplify them, and you'll have all the other ones. The other one you're going to want to memorize is the other one that we did here. So let's convert it. 30 degrees, if I multiply that by pi over 180, that's 30 pi over 180. What's that?
6 pi. No, pi over 6.
Pi over 6. You need to know that 30 degrees is pi over 6. Now, I can just count. That's 1 pi over 6. If I go another, this will be
Pi over 3.
2 pi over 6, which is pi over 3. 3 pi over 6.
Pi over 6. 2 pi. Yeah.
3 pi over 6,
Pi over 2. Yeah.
which we already had. All right, so we're just using that as a check mark. All right, next, 4 pi over 6. What's that simplify to? 2 pi over 3. Good. 5 pi over 6. 6 pi over 6.
Which is pi.
I already had that one. Good. So we're still on track. 7 pi over 6.
6. 8 pi over 6. 9 pi over 6. 9 pi over 6.
7 pi over 6. This one is 8 pi over 6, which simplifies to
4 pi over 3.
mhm.
9 pi over 6.
This one would be 9 pi over 6, which simplifies to
3 over 2.
good. 10 pi over 6.
5 pi over 6.
Which is
5 pi over 3.
Which is pi.
5 pi over 3. 11 pi over 6.
No, you can get
And then 12 pi over 6. There you go.
Oh, yeah.
Right? So by memorizing these two things and being able to count, you can get all of the angle and radian measurements that you guys need. Notice which ones were the most important. 30, 60s, 90s, and 45s. We are going to use this a ton next year.
No.
Okay, I'm going to stop us there. I'm going to move everything back one day. So I think I had your quiz on Tuesday. It's now going to be on Wednesday. And I want to finish the examples using the unit circle tomorrow.